Good morning. Today we are going to see the first chapter in chemistry, that is solid state. Now you have learned about solids in your lower classes. Let us discuss some of the properties of solids. The first important property of solid is that they have definite shape, mass and volume. The second property is the intermolecular distances in solids are short. So, as the distance between the molecules are short, there is a very strong force of attraction between the molecules. Now, the solids are incompressible and also they are very rigid. Again, the constituent particles, now when I say the word constituent particles, it means atoms, molecules or ions. Now the constituent particles in a solid are fixed or they are in a fixed position, which means they can only oscillate about their mean position. So these are some of the important properties of solids. Now in this chapter you will learn about the classification of solids, about unit cells, how to find the density of a solid. Also you will learn about the packing efficiency of solids and also about the imperfections in solid. So first let us see about the classification of solids. Now the first classification of solid is based on the nature of order present in the arrangement of constituent particles. Nature of order. So depending upon the arrangement of constituent particles, we can classify solids into two types. The first is crystalline solids. And the second is amorphous solid. First, let us see what is a crystalline solid and its main properties. Now, what are crystalline solids? A crystalline solid consists of large number of small crystals, each of them having a definite characteristic geometrical shape. Or we can say, in crystalline solid, the constituent particle have an orderly arrangement and they have a definite characteristic geometrical shape. Now let us see what are the important properties of a crystalline solid. Let us see about the order present in crystalline solid. We can say that crystalline solids have long range order. Now, what do you mean by long range order in crystalline solids? Crystalline solids has a long range order, which means that there is a regular pattern of arrangement of particles which repeats itself periodically over the entire crystal. So, anywhere in the crystal you see that particles will be arranged in a definite pattern. That is called long range order. An example for crystalline solid is sodium chloride, then quartz. Quartz means silica, SiO2. This is an example for a crystalline solid. Now, coming to the melting point of crystalline solid, they have a very sharp melting point and they are called true solids. As they have a very sharp melting point, they are called true solids. Next, let us see the cleavage property of crystalline solid. Now, when cut with sharp edge tool, they break into two pieces and the newly generated surfaces are plain and smooth. Now, next, let's see about heat of fusion. Heat of fusion in crystalline solid. What do you mean by the term heat of fusion? It is the heat absorbed by a solid at its melting point that converts the solid into liquid. that is heat of fusion. And we can say for crystalline solids, they have a definite and characteristic heat of fusion. Now, next, the last important property of crystalline solid is anisotropy. Anisotropy. Now, what do you mean by anisotropy in crystalline solid? Or we can say crystalline solids are anisotropic in nature. Anisotropy means the different physical properties like electrical resistance and refractive index have the different values when measured along different directions in the same crystal. So, anisotropic property of crystalline solid means some of the physical properties of solids like electrical resistance and refractive index show different values when measured along different directions in the same crystal. And why these values of physical properties are different? This is because of the different arrangement of particles in different directions. Now, I have drawn here a crystal with particles in it, and if you we can show the anisotropy due to different arrangement of particles along different directions. If you take this direction, see the arrangement of particles, and the particles are same. And here, if you take in this direction, the particles are different. The arrangement is different. So, we get different values for physical properties. Okay, that is the meaning of the word anisotropy. Now, let's come to the second type of solid, that is amorphous solids. Amorphous solids. Now, what are amorphous solids? Amorphous solids, they do not have a regular pattern of arrangement of constituent particles, or their shape is irregular. Or we can say they have a short range order in them. Short range order. What is the meaning of short range order? Short range order means there is a regular and periodically repeating pattern which is observed only for short distances. Such portions are scattered and in between the arrangement is disordered. So, we can see this arrangement of constituent particles in a definite pattern for a short distance only. So, it is called short range order. Now, next, coming to the melting point of amorphous solid. The amorphous solid gradually soften over a range of temperature. They can be molded and blown into various shapes. Now, amorphous solids are called pseudo-solids or supercooled liquids. They are called pseudo-solids or supercooled liquids. And example for amorphous solid is glass, rubber, plastic. Then we have quartz glass. Quartz is crystalline, whereas quartz glass is amorphous. So, these are examples for amorphous solid, and they are called pseudo-solids or supercooled liquids. Means, like liquids, this amorphous solids also has a tendency to flow. So, we can call glass is a supercooled liquid because it has a tendency to flow. And you can see in glass panes fixed to windows or doors of old buildings are slightly thicker at the bottom. That's because the glass flows down very slowly and makes the bottom portion slightly thicker. So, amorphous solids are called supercooled liquids or pseudo-solids. Now, next let us see about the cleavage property of amorphous solid. When cut with a sharp edge tool, they cut into two pieces with irregular surfaces. Now, the next property is about heat of fusion. They do not have a definite heat of fusion. And the last property is amorphous solids are isotropic in nature. Isotropic. Now, anisotropy means the values of physical properties are different along different directions. Isotropy means the values of physical properties are same in any direction. So, amorphous solids, they are isotropic in nature because there is no long range order in them and the arrangement is irregular along all the direction. So, the value of physical property would be the same along any direction. So, these are the important properties of crystalline and amorphous solids. Thank you.